we're going to use the same key val. However, we're going to use multiple fors. So we're going to say for key and keys, for val and values. Welcome back to Understanding Python. My name is Jake, and today I'll be talking about comprehensions. Comprehensions can be challenging to understand if you're new to the syntax, but after this video, you'll know them in and out. Understanding and mastering comprehensions will add another powerful tool to your Python belt. This is a subject we've been building up to for a number of videos now, so for this video, you need to be comfortable with for loops, as well as conditionals, lists, and dictionaries. If you're not familiar with these subjects, please pause the video now and watch the previous videos on those subjects. To start, I'm going to construct a list how you would normally see a list constructed. We'll call this test list is equals to an empty list, and then we're going to use a normal for loop to populate that list. For I in range 5. And then test list dot append I. So we're adding I to the end of the list each time we go through the for loop. However, that took 3 lines to write out. Also, we had to create the list before we ever started adding any data into it. Comprehensions allow us to compress this particular example into 1 line, and we can both define and populate the list at the same time. So let's take our previous example and change it into a comprehension. So we'll change the variable name just to make sure that we don't have any conflicts later on as we print this out. And the first thing we're going to do is take our for line except for that colon. We're going to remove that, straight up delete the colon, pop that inside of our list. And then the next thing is, instead of saying comp.list.append I, all we really care about is what we're actually appending to the list, which is I itself. So we can get rid of this, and then just take I, put that at the beginning. So a comprehension looks like I for I in range 5, meaning I care about I for every time I go through the loop for I in range 5. So the basic syntax of this comprehension looks like this. Variable is equal to statement for value in iterable. Now there's another thing beyond iterable, but we'll cover that a little bit later in the video. Now why do I say statement instead of a variable? Because while it's true that I is a variable, it is also a statement. And in comprehensions, it's the statement that we care about, and this is a statement that'll be evaluated and put into whatever you're constructing. To illustrate this, I'll create a list of squared numbers. First, we'll show the normal method, squares. It's equal to an empty list, and then for I in range 5, we'll append I ** 2. If you've not seen that before, ** in Python means to the power of or exponent, in this case 2. So it'll be I times I, or simply I squared. Now to put this in comprehension form, again, we'll copy, paste it down here, change the variable name to square comp. Sure. Copy our for statement, get rid of that colon, put the for inside of our list brackets. Now we don't care about the append statement here because that's implied. Instead, we care about this I ** 2. So copy that, get it out of there, and put it at the beginning of our comprehension. And now we have square comp equals I to the power of 2 for I in range 5. Easy enough. Now in line 7, I alluded to there being something after iterable, and that is that we can add one or more conditionals to our comprehension. An easy way to show this would be to construct a list of odd numbers. Again, we'll use the ALL method here. For I in range, we'll go up to 10. And if you remember back to my video on conditionals, you'll remember that Python has a modulus operator, or simply an operator that divides by a specific number and returns the remainder. So anything that is divided by 2 and has a remainder is odd. We can check for this with the truthiness of the following statement. If I modulus 2 oddlist dot append I. So if we have a remainder when we divide our number by 2, add it to the odd list. Now let's put this in comprehension format. Copy it, paste it. Change this to odd comp. Again, we're going to put our for statement in between the brackets. And then next, we're actually going to copy our if statement. So if I modulo 2, copy that, get rid of that colon, put it to the end of our comprehension. And then just as before, we don't care about the append. We just care about this I here. So we'll put it up to the beginning of our comprehension. And now we have odd comp is equal to I for I in range 11 if I modulo 2. Or simply give us all values of I in range 11 if there's no remainder if I is odd. Okay, I'll add some print statements to this and we'll take a look at each of these. Our print statements are in place. We saved. Let's run it. Give yourself a bit of room to take a look at each of these. And then under intro, we have test list 0 through 4, comp list, the exact same values, but we did it in just one line. Squares, we have 0, 1, 4, 9, 16. Same thing with square comp. Same values, shorter. Odd list and odd comp are exactly the same. We're seeing a pattern here. They do the exact same thing, they're just shorter and a bit more efficient. Now aside from just lists, there's a few other comprehensions that we can do. The first that we'll show will be a set comprehension. A set comprehension follows the same syntax as list comprehensions, the difference being that it's enclosed instead of in square brackets, we have curly braces. So we'll create a simple set comp called set comp and put that between our curly braces, I for I in range 5. Really simple. Not trying to show you anything spectacular here, just show you the difference between a list and set comprehension, and that's just the braces on the outsides. Everything else in the inside is exactly the same. Now something else that's very similar in syntax is what's known as a generator comprehension. Generators aren't something that I have covered yet, but it is something that I'm going to cover in a future video. You don't have to worry too much about what a generator is right now. Just know that the syntax for a generator comprehension is similar to what we've seen above. We'll call this generator comp. And for a generator, we surround it in normal parentheses. I for I in range 5. Easy enough. Now, Slightly more complicated and something that's getting a little bit beyond beginner level comprehensions is dictionary comprehensions, but the syntax is similar, so stick with me here. We'll add a comment in here, dictionary comprehension. And our first dictionary comprehension we'll intelligently call dictionary comp. Now, if you remember back from our video on dictionaries as well as basic data types, dictionaries use our curly braces as well. However, what differentiates a dictionary from a set is that we use key value pairs. So that's what's going to be different in our comprehension. We have to set both the key and the value. So for this, let's start with our for statement. Again, we'll use something that we've been using the entire video for I in range 5. Now at the beginning, we need to set a key value pair. So what we can do is explicitly cast I into a string for our key, and then the value for that key will be just I itself. Easy enough. So we'll add another comment up here updating the syntax. Now, what if you didn't want your key and value to be based on the same value in your for loop? Well, looking back at our previous video on unpacking, we can unpack values as we go along. So let's set some initial things to iterate over. We'll have keys is equal to simply A, B, C, D, E. And that's just a string. And then our values will be explicit casting into a list of our good old range 5. And then our new dictionary comprehension will look like this. Key, colon val, for key, comma val, in, and then we're going to zip together keys and values. So this is going to pair together each item in our keys with each item in our values as it goes along. So A will map to 0, B 1, C, etc. Now there's another way we could have done this, and this is going to push you even further into that intermediate category. And we'll call this one dictcomp2. We're going to use the same key val. However, we're going to use multiple fors. So we're going to say for key and keys, for val and values. Right now you may be thinking, Jake, that's too much. What's going on here? So we'll write this out in a normal flow so you see exactly what's happening. Dictcomp2 is equal to an empty dictionary. And then we're going to use a for loop here for key and keys. And then underneath that, another for loop, so a nested for loop for val and values. And then we're adding that key value pair. Key is equal to val. So all we did to construct this is add this for loop, and then immediately after we added this for loop. And then just as before, we care about the key and the value mapping. So that's what we put up here. If you have any questions on this, please feel free to add a comment down below and I'll be more than happy to clarify. Okay, I'll add some more print statements and we'll take a look at each of these. All right, those prints are in place. It's saved, print, and expand. Okay, if we look at setComp, we see its values is a set from 0 through 4. The type is class set. If we look at our generator comp, it doesn't have any values because it's a generator object. and its class is generator. For a dictionary comprehension, values is a dictionary with string keys and integer values. And of course, its class is a dictionary. And if we looked at our other two shorter dict comp examples with the key value pairs, we see two different ways of doing it, but with the same end result. Okay, that wraps up the beginner section. Next, I'm going to move on to the intermediate examples in this. Now, this section may be a bit more difficult if you're a beginner. However, feel free to stay, as this will be building on concepts you're already familiar with, especially if you've been following this series. Okay, so for intermediate, let's clear this and jump right into it. We're going to do this relatively quickly. All right, the first thing that we're going to cover in the intermediate section is nesting. So not only can you define a single list, set, or dictionary, you can define multiples, one level nested under another. Being known for my creative variable names, we'll call this nested. Now to make this a bit easier to read, we're going to put this down onto a next line. So we have our outer list starting on line 3, ending on line 5. And then our inner lists are going to be x times y for y in range 1, 11. So going 1 through 10. And then this is going to happen for x in range 1, 11. Sorry, up here instead of I it should be y. You may be thinking, how does this list have access to the x variable? Well, this can be rewritten as for x in range 1, 11, and then for y in range 1, 11. And then our action is underneath of that. So you see that x is inside the scope of this y for loop. And then not only can we nest our loops, we can also use multiple ifs at the same time. So we'll call this multiple ifs. And since there's going to be a lot packed into this, we'll also indent this. We'll use an f string with the values char and then num. And that's going to be for char in capital A, lower b, capital C, D, lower e, in a string. This will make sense in a second. For num in range 26. And that's going to be only if char that is upper. Also, if not num modulo 5. So with these two if statements, we're only going to be picking out when we have A, C, and D, reverse that, and when num is divisible by 5. And then our final example is we can also expand the logic in our statement section to use inline ifs. So for our inline if example, we'll do a dictionary comprehension, mapping x to a nested list, and this is going to be 1, if not x, times y is divisible by 4, else we're going to give a 0. And that's going to happen for y in range 1 through 11. And each of those is going to happen for x in range 1 through 11. Okay, I'll add some print statements and we'll take a look at each of these. Okay, our print statements are in place, and let's take a look. And it looks like I did the I thing again. Let's change that real quick. Save, run. Here we go. So for our nested, you see we have an outer list here spanning from there to there. And inside we have 1 through 10, 2 through 20, etc. So this is effectively our multiplication tables. For our multiple ifs, we have an interesting mapping of uppercase letters to numbers that are divisible by 5. So that's A0, A5, A10, etc. And then our inline if, we have the number that we're multiplying by mapping to a list of true or false values in the form of zeros and ones if that number in that position is divisible by 4. Well, that wraps up this video. Now that you understand comprehensions, you can quickly create lists, sets, and dictionaries and generators. What is your favorite comprehension trick? Or is this something I showed today? Leave a comment down below to let me know. As always, today's code will be added to the Understanding GitHub repo, so check the description for a link. And of course, if you have any questions or suggestions for topics you'd like me to cover, leave a comment for me. To keep up with this series, please consider subscribing. Thanks for watching.